Welcome back to World Decoder. We explore the hidden mechanics of global military power and the secrets behind modern geopolitical strategies. In our journey decoding Iran's military might, we have explored underground missile cities and the overwhelming tactics of drone swarm warfare. However, a critical question remains unanswered. How does a nation under heavy sanctions defend its skies against invisible, high-tech stealth aircraft? Can a country isolated by economic blockades truly claim that multi-million-dollar stealth superjets cannot penetrate their sovereign airspace undetected? Today, we return to the field to decode the missing puzzle piece, a formidable shield known as the Bavar 373 system. This is the magic eye, designed specifically to hunt stealth ghosts, challenging the supremacy of advanced Western air superiority technologies. Chapter 1: The Birth of Persian Pride. The Bavar 373 is not merely an air defense system. It is a symbol of resilience. It represents the result of a dramatic journey of self-reliance, born from the necessity to survive amidst severe international military restrictions. After the vital contract to purchase the S-300 system from Russia was delayed for many years, Tehran faced a critical choice. The Iranian engineers and military strategists decided to take matters into their own hands and create a purely Persian defensive system. They mobilized their scientific resources to build a weapon that did not rely on foreign support or external software codes. The result is a sophisticated system that Tehran confidently asserts can rival and, in some specific metrics, even surpass the S-300. Its primary design philosophy focuses heavily on confronting the new generation of stealth technology that dominates modern aerial warfare doctrines. Chapter 2: Technical Decoding. We examine the AESA radar and the intricate game of wavelengths that defines modern electronic warfare. Why can advanced stealth aircraft like the F-35 or the B-2 Spirit potentially be detected by the Iranian Bavar 373 system? The secret does not lie simply in having a more powerful radar, but in the specific frequency bands that it utilizes. World Decoder now breaks down the fundamental physics. Let us look at the Active Electronically Scanned Array, or AESA radar. Older radars emit a single beam. This makes them vulnerable to jamming and allows the enemy to calculate their location. The Bavar 373 uses a new generation AESA radar with thousands of independent transmit and receive modules working in perfect harmony. Instead of one beam, it emits hundreds of continuously varying waves, making it impossible for the enemy to find a pattern. This chaotic shifting prevents the opposing aircraft from hiding effectively or launching electronic countermeasures to jam the incoming detection signals. Next, we enter the bandwidth war. This is where the physics of stealth technology meets its natural physical limitations. Current stealth aircraft are designed primarily to deflect X-band waves, which are short wavelengths used for precise missile guidance targeting. However, these aircraft designs are surprisingly vulnerable when exposed to longer wavelengths, such as the L-band or VHF frequencies. This creates what we call the long wave trap. The Bavar 373 radar integrates the capability to scan using these long wavelengths. In this frequency range, the sophisticated curves and angles on the stealth fuselage lose their effectiveness against the incoming radar energy. The long radar waves crash against the entire aircraft body like a ball hitting a wall, creating a clear reflection signal. This reflection returns to the source, revealing the position of the aircraft that was supposed to be invisible to radar. Chapter 3: Intelligent Command and Control. A powerful radar is useless without a brain to process the massive amounts of data. The Bavar 373 utilizes advanced algorithms for multi-point data analysis, synthesizing information from various sources to create a coherent battlefield picture. It combines signals from multiple radar stations placed far apart. This network is the key to defeating stealth deflection techniques. When a stealth aircraft attempts to deflect radar waves away from the source to avoid reflection, it falls into a trap. The satellite radar stations of the Bavar 373 network catch these deflected waves from different angles, exposing the aircraft's hidden location. The central computer then synthesizes all of these fragmented signals, calculating the exact trajectory and speed of the single aerial target. This fusion of data ensures that even if the aircraft is invisible to one radar, it is visible to the network. Once the target is identified and tracked, the system transitions instantly from passive surveillance to active engagement and interception protocols. Chapter 4: The Talons of Syad 4B. Detecting the target is only half the battle. Destroying it requires a formidable weapon. To eliminate the threat after detection, the Bavar 373 is equipped with the Syad 4B missile, a masterpiece of Iranian engineering. With an operational range of over 300 kilometers, it provides a massive umbrella of protection over strategic national assets. It is capable of reaching high altitudes, touching the edge of the atmosphere to intercept not just jets, but ballistic missiles. The combination of the Magic Eye scanning long waves and this long-range missile creates a formidable wide-area defense system. This effectively establishes a genuine no-fly zone over Iranian airspace, deterring potential aggressors from attempting any surprise aerial incursions. The precision of the guidance system ensures that once the target is locked, escape becomes statistically unlikely for the intruder. This kinetic capability proves that the system is not just a theoretical deterrent, but a practical shield ready for combat. World Decoder concludes, the Bavar 373 stands as a testament to using fundamental physics to overcome expensive proprietary technology. By focusing on the inherent weakness of stealth technology, which is its allergy to long wavelengths, Iran leveled the field. They have created a magic eye that makes every aerial intrusion significantly riskier than military planners ever anticipated. This system proves that determination and scientific understanding can forge a shield capable of challenging the world's most advanced air forces. The strategic balance in the region shifts when the assumption of air superiority is no longer guaranteed by Western powers. Global analysts must now recalculate their risk assessments when considering operations within the range of these Persian defenders. And the story does not end here. The evolution of this system continues, promising even greater range and precision ahead. From the physics of wavelengths to the engineering of heavy missiles, we have decoded the layers of this formidable defense. Do you believe that physics-based counter-tactics will eventually render stealth technology obsolete in the future of modern aerial warfare? The skies may look empty, but the invisible eyes of the Bavar 373 are always watching, waiting for the slightest disturbance. If you enjoyed this deep dive into military technology, please like this video and share it with fellow enthusiasts. Stay tuned for our next episode, where we will uncover more secrets hidden beneath the surface of global defense strategies. Thank you for watching. Keep questioning the narrative and looking for the physics behind the politics. This is World Decoder. Let us take a brief moment to appreciate the solid fuel propulsion technology that allows for such rapid reaction time. Unlike liquid-fueled rockets that require fueling time, solid fuel missiles are ready to launch at a moment's notice. This mobility allows the battery to fire and relocate immediately, avoiding retaliatory strikes from enemy anti-radiation missiles. This shoot-and-scoot tactic is essential for survival in a modern battlefield saturated with satellite surveillance and drones. The system also integrates with passive radar elements, which listen for enemy emissions without revealing their own position. This adds another layer of stealth to the defense system itself, making the hunter invisible to the hunted aircraft. The human element remains crucial. Highly trained operators work in shifts to ensure 24-hour readiness against any threat. Despite constant surveillance from foreign satellites, the exact locations of these mobile batteries remain a difficult puzzle to solve. Deception, camouflage, and electronic decoys are employed to protect the valuable radar systems from preemptive suppression attacks. Economically, the exchange favors the defender. A missile costs a fraction of the price of the aircraft it destroys. This asymmetric cost ratio forces aggressors to think twice before risking expensive assets against relatively affordable defensive interceptors. Lessons learned from recent conflicts globally have reinforced the importance of ground-based air defense in modern military doctrine. Iran actively incorporates these global lessons, constantly updating the software and tactics of the Bavar 373 to stay relevant. Live fire exercises are conducted regularly to test the limits of the hardware and the nerves of the operating crews. This confidence is not just propaganda, it is backed by a tangible hardware capability that demands respect from adversaries. The program also cultivates a new generation of engineers, ensuring that the knowledge base for defense technology remains domestic. Reducing reliance on imported microchips and components is the final frontier in securing the system against external sanctions. As we look at the map of Iran, we see not just land, but a fortress protected by an invisible shield. Bavar 373 is the long-range layer, working in concert with other systems to create a dense, multi-layered air defense network. Ultimately, the goal of such a powerful system is deterrence. to prevent war by making the cost of aggression too high. At World Decoder, we remain committed to analyzing these developments objectively, stripping away the rhetoric to find the facts. We extend our gratitude to our community for supporting this channel and enabling us to produce high-quality defense analysis. From the mountains of Zagros to the shores of the Persian Gulf, the landscape is now watched over by these machines. As technology evolves, the eternal cat-and-mouse game between the spear and the shield will continue to drive innovation. Don't forget to subscribe and hit the bell icon so you never miss our next deep dive into military tech. World Decoder, signing off.